In the previous class, we had discussed about the addressing mode and we have stopped the discussion by indirect addressing. Let's continue the same by taking an example. So here we have taken an example of adding the numbers, you can see. So n what we have taken is the number of data you want to add. Maybe for example n is equal to 4, which I will store in R1. Therefore R1 will be acting as a counter. Now to indicate this effective address, the locations of the next successive address, we need a pointer, and that pointer we have taken it as R2. So already we have discussed the effective address is nothing but it will provide the information from which the memory address of the operand can be determined, right? So that effective address nothing but the next successive location we need to point to, so that we will be using a pointer, and that pointer is R2. To store the result we are taking R0. Next, so here you can see we have an instruction add R2 comma R0. So this R2 is nothing but it is giving you, it is pointing you to the next location. You can take the data from that location, you can store that data with R0 and store back the result in R0, right? Next we are taking add hash 4 comma R2. Why hash 4 is if you are in location 0, right, if you are in location 0 to go to the next location. So we have already discussed in 32-bit processing the addresses will be like 0, 4, 8, 12, right? You remember, I think. So to the from 0 to go to the next location it is 4. From 4 if you want to go to the next location it is 8. So that's why every time you will be adding 4. So now just we will take out that example here. So I said n is equal to 4, I'll take n is equal to 3, which will be stored in R1, which is acting as a counter, right? So now R0 is you are using to store the final result. So initially you are making it as 0. Next to point to the successive addressing locations, we will use R2 as a pointer. So the address locations are 0, 4, 8, 12, right? The locations, the names locations what we have taken is num1, num1, num2, num3. To point each location we are using the register R2. We are using the register R2. The data which is stored here, I will say 1, 2, 3. So first what you will do, you have an instruction which says add R2 comma R0, which means the data which is pointed by R2 you have to take it, add with R0 and store the result in R0. Now initially your R2 is pointing here. So what is the data present here is 1. Take that 1, add with R0, you have 1, store the result in R0, right? Initially R0 was 0, now it has become 1. The counter it is 3, now it has been decremented, so it will become 2. Whether 2 is greater than 0? Yes. If it is yes, then go to the next location. The next location is pointed by R2, it is showing to here. It is showing here, so nothing but the address 4. So that is what we have done, add 4, right? Add 4 comma R2. So you are in 4th, second location. The data present here is 2. Take out the data 2. Initially R0 is holding 1. So previously 2 plus 1 is equal to 3. After first addition R0 was holding 1. Now after addition it is holding 3. Decrement the counter, it will become 1. Is 1 greater than 0? Yes. If it is yes, go to the next location. That is here. Pointed by R2. Location address is 8. What is the data present here is 3. Next. 3 plus 3 is equal to 6. Now R0 is becoming 6. Decrement R1. So it will become 0. As it is become 0, you have to exit the loop. So we have taken the addition of the numbers like 1 plus 2 plus 3. So 1 plus 2, 3, 3 plus 3 is 6. So the same thing we have discussed by taking an example with the implementation of indirect addressing mode, where R1 is acting as a counter, R2 is acting as a pointer, and R0 is acting as a register to store the final result. After this loop is done, then what you can do, you can move the data which is present in R0 to the location sum. So here you have a location, that location I will say it as sum, which is present, the final result what you have present in R0, you can send it to location sum. This is how we are doing the addition of the number by taking an indirect addressing mode. Continue the next kind of addressing mode that we have called as index addressing modes. Nothing but indexing and arrays we say. So here in indexing an array, the effective address is calculated by adding a constant value to the content of a register. Now you can see the register Ri, it will be holding some location address, right? Memory location address. If you go to that location, you will get the it will get the information from where you can get the data. Now along with this Ri, you need to add a constant value. That constant value we have taken it as x. You have taken a constant value that it has x. If you go to the total adding after these two, that is effective address is equal to x plus Ri. This will be the location where you have to get the information. So this kind of addressing we call it as index addressing. That is, you need to add a constant value to the content of the register. See here, you have taken an instruction add 20 R1 comma R2. So initially in the previous example, if you go to the location R1, right, it was giving you 1000. If you go to that 1000, from where you can get the information about your data. Now R1, along with R1, you can see we have written 20. It says that you need to add 20 to the content of R1. So this is R1. This is R1. What you are doing now, you are adding 20. When you do 20, you will have 1020, from where you can get your operand. This is when R1 is holding 1000. In the other case, you can make R1 to store 20. Then, right, this is the location. You can see the instruction here. It is 1000 plus R1. So 1000, R1 is holding the offset value. If you go to the final address 1020, you will be getting an operand. This is this kind of addressing mode we called as index addressing mode. And let's understand this addressing mode by taking an example. So here in this example, we are trying to take few students, and that students ID and their marks we are trying to store in the locations, and finally all these test marks we are trying to add and store in the different locations like sum1, sum2 and sum3. You can see here already I have said with respect to indirect addressing mode, we will be using a pointer. So here you are using a pointer, so that pointer is R0. You are using a pointer R0. You are using 3 register to store your marks R1, R2 and R3. Now R4 is acting as a counter where every time it will be keep on decrementing. To store the test marks final result, you are using the location sum1, sum2 and sum3. We have named it as list, right? So we will give the locations now. It is 0, 4, 8, 12, 16, 20, 24, 28, 32, right? To point this to point this location, we'll go for a pointer register. That pointer register we have taken it as R0, right? Next, what you have, you'll need a counter. That counter we have taken it as R4, which is equal to n. You can take any number of students. In the first location, you will be storing the ID. In the first location, you will be storing the ID. In the next 3 location, you will store the marks test 1, test 2 and test 3. This is for student 1. Similarly, for the second student, in the next location itself, you will store ID, then test 1, test 2 and test 3. This is about student 2. Similarly, you can take any number of students. Now, we have already said we are trying to store the ID and numbers of the different students, and finally you will be adding them and store in the result in the different locations, right? What we have taken R0 as a pointer now. This is location 0 where you are storing ID, right? In the next 3 locations, you have taken T1, T2 and T3. You have taken T1, T2 and T3. From 0 to 4, if you want to move, how much you need to add? 4, right? If you want to move 0 to 8, then you need to add 8. If you want to move 0 to 12, then you need to add 12. So we have the instructions which says 4 R0, comma R1. Next it has 8 R0, comma R2 and 12 R0, comma R3. That is 4 R0, comma R1, 8 R0, comma R2 and 12 R0, comma R3. So in the location 0, you had stored the ID. In the next location, you have to take the data. You have to take the data which was present in that location, right? Then you have to add it with R0 and store it in R1. Next take it from next location 8 and next location 12, right? So that is why we have taken the instruction add 4 comma R0, 4 of R0, comma R1, 8 of R0, comma R2, 12 of R0, comma R3. So this is about student 1. If you want to go to the second student, the information is stored in the location 16, 20, 24 and 28. Now you are pointing here. If you want to store the ID of the next student, then the location is 16, right? That is why you need to go for the next instruction which says add hash 16 comma R0, so that you can come over here and you can store the next ID, right? That is why you will be using add hash 16 comma R0. Once the student ID is stored, the next thing is to store the marks T1, T2 and T3. The next marks, again we will be taken the instruction 4 of R0, comma R1, 8 of R0, comma R2 and 12 of R0, comma R3. So 4, 16 plus 4. When you say 4 of R0, comma R1, R0 is pointing here 16. The next data what you have, it is in the location 20. Therefore, you will be doing 4 of R0, comma R1. Now R0 is pointing 16. When you say 16 plus 4, it will be pointing to 20, right? Then you can take the data. You can add it with take the data and you can move it to R2. R1, sorry, you can move it to R1. Next, the next marks it is stored in 24. So 16 to 24 if you want to move, then you need to add 8. That is what? 8 of R0, comma R2, 8 of R0, comma R2. So 16 plus 8, 24. You will come to this location. You take the mark and send it to R2. Next, the next marks is stored in 28. Therefore, if you want to move to 28 from 16, then you need to add 12, right? That is why it is 12 comma R0. 12 plus R0. 12 plus R0 is nothing but 16. You will be coming to 28 and you can take the marks and you can send it to R3. Like this, you can take out any student information which are stored in the different location. To point to this location, we have taken R0. To go to the successive locations, we have taken 4 of R0, 8 of R0 and 12 of R0. In the first location itself, we will storing the ID, then we will store the marks, then ID we will store the marks, right? Finally, all these marks will be added and it will be stored in the locations like sum 1, sum 2 and sum 3. In the same page, we have to continue. It will say sum 1, sum 2 and sum 3. So here the things are clear. In the first location, you will be storing the ID. In the next successive locations, you need to go to store the marks. So for that, you have taken the instructions. You can see here add these three instructions. These three instructions is to say about the next continuous location from where you can get the information of marks, right? To store the next ID, you have to jump to the next location. So that is why you are doing hash 16. So I have shown you the example. Next, you will be using R4, which is acting as a counter. So after every student information, you will be keep on decrementing it. If it is greater than 0, then you have to go back to loop. And after this, every marks will be added and it will be stored in the location sum 1, sum 2 and sum 3. If you are in the locations 0, 4, 8 and 12. So this is to store ID. These three is to store your marks, right? If you want to go store the next student ID, then it is at the location 16. That is why you have used the instruction add hash comma hash 16 comma R0. Add hash 16 comma r0. So already said r0 is acting as a pointer, so r0 will be pointing over here. So when you are adding 16, then is 0 plus 16 you will come over here. So now you can store the id. After this you will be having the successive locations where you can store the marks t1, t2 and t3. So they are at the location 20, 24 and 28. To move to the 20, 24, 28, you have the instructions which says add 4 of r0 comma r1, add 8 of r0 comma r2, right? So if you are here 16, the next location, to move to the next location you have 20, that is why 4 of r0. So r0 is here, 4 of r0 is 16 plus 4 is 20. Next, for test 2, it will be 8 plus 16, 8 plus r0. r0 is 16, 16 plus 8, 24. Next is r0 plus 12. So r0 is 16, 16 plus 12 is 28. So here you can have the test 3. After this, you can store the id of next student. The student id will be at the location 32, right? Now you are in 16. r0 is pointing in 16. If you want to go to the third student id, to store the third student id, it is in the location 16. That is why you will again use the instruction add hash comma 16 comma r0. Nothing but you will be adding 16 to r0. So 16 is, sorry, r0 is pointing to 16. If you add 16, you will come to 32. So here 32 in the location you will store id. In the next successive locations you will store the marks 30, 32, 32 plus 4, 36, then 40, then 44. That will be holding the marks. Like this you have to store the information. At last you will add the marks of t1, t2, t3 and you will store the results in sum1, sum2 and sum3. This is about index addressing mode.